Sometimes I'm not a bastard, Haley. Sometimes. Sometimes I am. Yeah.
Aren't we all?
Okay, there we go. First, start by pressing not the stat button, but the program button. PRGM. It's directly below stat. Hopefully your screen looks something like this. Now, you may have other stuff in there too if you had other programs on your machine at the time. But if all you had was the 7 I gave you, points, disk draw, disk fill, GOF, sample size calcs, the normal, and until all. Some of these you'll never use. But the ones you definitely will use in this class are these 3. Disk draw, disk fill, and the normal. And we won't use the normal today. That's like, I'm thinking next week. Next week isn't Thanksgiving, is it?
Nope.
Week after.
Yeah.
Okay, good. Yeah, next week. Next week we'll get into that one. Now, these two kind of go together. Let's go to dist fill. When you press enter, it's going to kick you out to here. Press enter one more time to run the program. Now it should ask smallest x. Now before you, technically speaking, before you get into this, you have to know the situation that you're modeling in the TI. So let's model my chicken flock again. Let's model my 4 girls, or my 4 birds, I should say. My 4 birds, and we're modeling how many girls we could have out of that flock. Yes? That's the idea. Say that again.
At least 1.
0.
But I could have none, right? I know it's not likely, but isn't it possible that if I go to the store and buy 4 birds, that none of them are girls? It's possible, it's just not
Probably.
good. Not likely, not probable. I love that. I love that. So the smallest possible x value is going to be 0. And for a binomial, it's always going to be 0. Because no matter how unlikely, it's still a possibility. There's still a possibility that nothing will happen, that you won't get any of what you're looking for. So for ours, 0 is the smallest for our chicken flock. Cool? Fair enough. How about the largest x value? In my case, it's 4, right, Haley? Yeah, it's 4 because I bought 4 birds. Ideally, I want 4 girls because I want them for the eggs, not to make more babies. Cool? So you put in 4, you press enter. Now at this point, the TI has filled L1 with 0, 1, 2, 3, and 4. It's just L1 is filled now. So your x column is done. It now wants you to tell it what's in the P of x column. What are the probabilities? This is where the work happened yesterday. You guys figured the x column out in like 20 seconds. But then it was the challenge of the 0.9s and the 0.1s. Where are they? And you figured that out pretty quickly too. And then it became the coefficient. And then you started getting frustrated with the 4, with the damn 6. Why is it 6? It's okay. I totally get that. I also agree that you don't have to worry about that too much. Let the technology take it. I find this funny. David Moore, you don't know who this is, and that's okay. He writes stat textbooks that's his job. I actually have a quote from him saying, I don't know why we still teach the binomial distribution. Why don't we just give the kids programs, use technology to get and then interpret the probabilities? And I'm like, dude, you write textbooks and you include the formula in your textbooks. Hypocrite. But even a textbook writer admits that it's more important to know what the numbers are than how to actually get them mathematically. And that's what this is doing for you. So I just find it funny that even a textbook author admits that he's a fraud. Anyway, we're going to fill it with a binomial. So just pick number 1. The rest of it you can ignore. I made this more general, but it's probably too general. Just pick number 1. And then it wants to know what's the probability we're analyzing.
It's 90%.
0.9, 90%. We're analyzing the number of girls. You have to know what X is standing for. It's standing for the number of girls. The chance of a girl is 90%. So you got to put in 0.9 as a decimal. 0.9. Fair enough? You press enter. It says done. Very, very low tech. Very low tech. Very low tech. Done. Thank you. But now, what is... It is. Thank you for coming. I'm here all week. Now go back and look at your stat editor. Stat edit. There's your distribution that we spent probably 10 minutes putting together yesterday, if you think about it. It probably took us 10 minutes to build these probabilities, right? Because we had to figure out 1, 4, 6, 4, 1 for those multipliers, all those little Pascal multipliers we had to figure out. This does them all for you. And now at a glance, you can decide how nervous you are about getting a rooster. So at a glance, I know there's a pretty high probability that I'm going to get all girls. 65.6%, that's pretty high, that's like 2/3. Unfortunately, there's also a pretty high probability that I'm going to get 1 boy and 3 girls. Almost 30%. A little bit nervous about that, yeah? A little bit nervous. 5% is pretty low, so I'm feeling pretty good about not getting 2 and 2. 0.36% is ridiculously low. I'm feeling pretty good about not getting 1 girl and 3 boys. And now, Aaron, again, the 0 is very unlikely, 0.0001, but it's still possible, just not likely. But you get all of them here. Please, Sandy, yes?
I forgot. Why does it say 1E?
Because the TI will not give you anything like past... You know what's weird? You asked this question, and now I don't know the answer, because this is 0.0001,
Yeah.
which is 4 decibels. So is that. So why isn't that 3.6 e to the negative 4? It won't fit, that's why. Son of a bitch, it won't fit, that's why. It's because this is too narrow. It's because if you look down, now let's see, it shows it down there too. I don't know why it's showing it there. It's because it won't fit in the visible space. You have to change it to scientific notation.
I couldn't even do...
Or you have to change it to a decimal. It is scientific notation.
Well, I did 0.1, like, to the... I think we did...
And then it changed it to that?
Yeah, it only says 1E.
Yeah, because it will always do that past a point, although I don't know why these aren't doing it. Yes, I do. Because 3.6 e negative 4 wouldn't fit in the screen. It's too many digits. Because it's just 1, if it was 1.1 e negative 4, it would put 0.0011 or 0.0001, whatever. It wouldn't.
It's only one.
It's only one.
It
Could be lines.
You know, because I guess...
So I'll give you a better answer. I'll give you a better answer.
I had to do it by hand to get that.
You did, of course. But here's a better answer. Just make peace with that.
Okay.
Make peace with what e negative 4 means. It means times 10 to the negative 4.
Okay.
That's what that e negative 4, and this is one of those things, if I had you guys in Math 95, which I didn't because I haven't taught Math 95 in years, I beat that into my Math 95 students. Not literally, I'm not that much of a pastor. But we do it all the time in Math 95. We're always getting those values because they're very close to 0, the e negative 5s, negative 6, negative 7s. And when I had Math 95 students, I made sure when they saw that they knew what it meant. And depending on who and how you had Math 95 or when, you've probably forgotten that. Yeah, Joanna. Oh, Becky's foot. I love her. She's so awesome, piece-wise. Yeah, she will. Because her and I, we actually wrote, because we're geeks, we wrote an appendix to the old Math 95 text, a big chunk of which was dealing with tech and dealing with the little errors and the goofy little TI hiccups. And she's wonderful. So yeah, so you're at peace with that. Now, the reason it's not just because of the TI, it's how Excel does these numbers. Excel will also use this language because Excel and the TI have a similar single line display. Why? Because they do. It's just, there's Bill Gates. Next time I see Bill Gates, I'll ask him. Oh, totally. It's just making peace with it, right?
Yeah.
It's like you drive on the right side of the road because if you don't, you're getting in an accident. We just got this. Nobody said it's right or wrong. It's just the way it is. Good. Please, David, go.
So 0 was the chance that we would get all roosters.
All roosters, no girls. Yes. Now watch this. Watch this. Check this out, Fred. I'm going to get your question in a second, Scotty. Don't change this on yours. But if I rerun that probability with 0 to 4 to 0.1, watch the distribution now.
So that's of the rooster.
This is the number of the number of roosters in my flock. What's the chance I get 0 roosters? Well, it's 0.6561. That makes sense, doesn't it? It's flip-flopped. Because 0 roosters means all chickens. So these probabilities are exactly reversed. Hence the binomiality of the niceness of a binomial random variable. You can look at either event, you just got to make sure you tell it which probability we're looking at. Is it girls or boys? Is that fair? You guys buying that logic? Hopefully that's fair. Good. Thank you, Haley, for making that connection. David, go.
Is that why you had said to the person chance of 1 in 3?
Let me get the other distribution back, if you would, David. Hang on 1 second. Let me just run the program again to get it back to what you guys have. 0 to 4, binomial 0.9. So this whole lesson for the past 2 hours was about that statement to that guy at the store. I love it when a whole idea comes out of a discussion from somebody.
Right.
When I told him, there's a 1 in 3 chance I got a rooster in this box, it's because in my mind I had approximated this number. Because the chance of getting all girls is about 2/3. That's about 2/3, right? Ish.
Yeah.
So that means the other 1/3, because I know this has to add to 100%, right? We know that. So if 2/3 of it's here, the other 1/3 of it has to have at least 1 boy in that box. And that's what made me nervous, right? Now I got nervous. I'm nervous. Now, I'm not going to lie to you. I was even more nervous. Oh, Scott, did you have a question? I'm sorry, you had a question.
Oh, no. I'm fine.
You sure? You're good, okay.
Keep going, yeah. It was just that I was going to say that the 1 to the negative 4, like the calculator automatically defaults to shorthand.
It's
and
what- yes.
And the 1 is actually the only significant figure that's in there. So
Exactly, that's
the
true.
only
That's
reason
true.
why
Get
it
ready
does
for
that.
more of them. We're going to see a lot more of them in this next example. Because the next example is how did I feel when we went back to the store in March and bought 4 more to add to our flock? Now, you can view that a couple different ways. You can be like, why would that be any different, right? It's exactly the same as this. And there's nothing wrong with viewing it that way. Look, that's one frame of reference. My frame of reference was I drew 4 more and threw them in with the mix, and now I've got a sample of 8. Now I got 8. So you could view it either way. You could totally view it, it doesn't matter, right?
Probably a new batch, though.
It probably is, but the probability of 0.9, I asked them, and they're still using 0.9. So even though it's a new batch, I'm assuming the sexing hasn't changed, the production of the chicks hasn't changed. I totally agree with you, Alicia. So that's why I say you can view it either way you want to. I viewed it as one large sample of 8. And then I got myself more nervous because I reran the math. Shall we? Let's rerun it again. Okay, let's rerun it again. So now we're analyzing, if you will. Hang on, let me show you the picture. We're analyzing this flock now. There.
That's nice.
So not Max, but the 8 girls that are around him. It's a Brady Bunch picture. So this is the eggs, but now we've got.
Why does he look terrified that he's holding eggs?
He's actually very
He's gonna drop him.
He's my son. I mean, he's got my facial expressions. I look terrified. You should see the picture. This thing takes snapshots during class. You should see some of the faces I make. It's ludicrous. Like, I can't believe you guys are still here. So, we've got the old girls. There's Mary, there's Nancy, there's Bertha, and there's Marge. But then we've also got Fern, we got Agnes, we got Gertrude, and we got May. So then I start getting nervous. Now I got 8, which means I know the chance of me getting all girls is going down, right? If I view it as one big chunk of 8. Now, Alicia can also view it as 2 chunks of 4. I'm not saying that's wrong. I'm saying I just chose to view it as one chunk of 8. So, if you rerun the program, just fill, what's the smallest number of girls I can get?
0.
I could have 8 roosters. I probably won't, but I could, right?
Right.
What's the most number of girls I can have?
8.
8. Okay? Make it binomial. Still binomial. 0.9. Still 0.9, because I asked the rancher at High Desert. Still 0.9. Okay. Took it a smidge longer to calculate that. See that one? Took it a smidge longer to calculate. Now if you go back and look at the stat editor, you have the new distribution. Now hopefully some of these numbers make perfect sense. 1e negative 8, that's 0.00000001. That's exactly what it should be. That's 0.1 to the 8th power. Right? And that should be that. You shouldn't be likely. You should not get 8 roosters if you buy 8 chicks that are sexed at 90%. You just shouldn't get that, right? I hope that makes sense. What's the chance you get 1 girl and 7 roosters? Pretty damn small, right? Pretty damn small. What's the chance you get 2 girls and 6? Thank you. Hit the subtraction. And 6 roosters. These are all very unlikely because you shouldn't have more boys than girls if their 90% should be girls. You shouldn't be having to flip-flop the other way. Hopefully that makes sense. Hopefully that makes sense. Good. Okay. This one's about 1/2%. Here's half the flock boys, half the flock girls. That's just about 1/2%. That's still very unlikely, isn't it? Yes. Here's 3.3%. Okay, now we're starting to talk about big numbers. Look, that's almost 15%. Now we're starting to talk about things I can be nervous about. 15% is large enough for me to start getting nervous. I'm not nervous about this. I'm a little bit nervous about this. Keep scrolling. Keep scrolling, friends.
Wow.
Right?
Crazy how much it jumps.
Isn't it, though? Isn't that cool? It's exponential decay. This is going back to 105 with you guys. It's exponential decay. You keep rolling the die, and that die has 10 sides. 9 of those sides have a G on them, and 1 of the sides has a B on it. If you keep rolling that die, what's bound to happen eventually? The B is going to be faced up eventually. Now look what happens. There's only a 43% chance they're all girls. That means it's more than 50-50 that I've got a boy mixed in there somewhere. Now here's the sad part statistically. I'll never know because 3 of the new girls are now dead. And they died before they started showing if they were a rooster or not. I'll never know if Gertrude was a boy. That could have been why Mary killed May. Or Fern. She killed Fern or May. I always forget this.
DNA.
She could have felt... Mary was an aggressive alpha female. If Fern or May, whoever she killed, if she was showing like qualities of a rooster and trying to like tame the flock, I can see Mary took on the roosters when we brought her to her new home. She went over after all 3 roosters. It was the most incredible thing I've ever seen. I'm like, holy shit, she's beating the piss out of him. It doesn't strike me if that little tiny bird was starting to show rooster capability, that she knocked it down and killed it. So that might have been, I may have had this case. Maybe Fern or May, I'm going to call it Fern, maybe Fern was a boy and the rest were all girls. They could have all been girls. There could have been three, or excuse me, all the ones that died could have been boys, which means I would have had 5 girls and 3 boys. Now that's not very likely, only 3.3%. So that's why I don't think that happened. But it could have been very possible that I had a boy mixed in there. It becomes more possible that I have a boy mixed in than that I don't. Isn't that amazing? Even though it's 90%, right? Even though it's 90%. It's still more probable that I do have a boy somewhere in the mix than that I don't. It's past a coin flip at this point. Kind of neat, huh? I had a buddy, or I have a buddy, I don't have.
I used to have friends.
Have had. His name's Mike Smith. You might remember him. He was an academic advisor up till maybe 2 years ago. He works for College Excel now. He heard me giving this talk down at the basement of the library once when he was working down there. And he'd go, Rule, I got a bone to pick with you. I'm like, all right, Mike, what do you got to talk about? He's like, I bought 7 birds at the store. And I got a rooster in the 7. I was like, well, congratulations. And he's like, no, I wanted all girls. And I'm like, well, just because you want all girls doesn't mean you're going to get all girls. He's like, yeah, but... And he knew the 90% figure. He's like, they're 90% girls. And I bought 7. Why shouldn't I get all girls? And I'm like, well, I bet you it's probably either really close to 50-50 that you would get all girls. He's like, how can it be 50-50 if it's 90? And that's a great question, isn't it? How can it be 50-50 if it's 90? Well, let's analyze Mike's flock, shall we? Let's analyze Mike's flock, which is, it's a little bit less than my new flock, if you will. Dance. All right. Let's analyze Mike's flock, Phil. So he bought 7 birds. What's the least number of girls he can have? 0. What's the most?
7.
7. Probability still 0.9. Okay, it's done. Go look at it. I showed him all this. Okay, here you go. Now look. He got a boy and 6 girls. That's Mike's flock right there. Should he be complaining about getting a boy and 6 girls? Lily's shaking her head no. Audra's shaking her head no. Why should he not be complaining?
Well, look at 7. You only have a 47 chance.
Oh, good. I wasn't even looking. I was looking at 6 right now. Randall's saying look at 7. I will look at 7 momentarily. But is that an outlier? Why is the event getting 6 girls and 1 boy not an outlier?
Because it's like some...
Say that again. Haley, go.
I don't know how to put it in
No, you got it. Say it any way you want to.
Like, it's like 9 out of 10. It's like 6 out of 7. So it's the... Like
8.
the 90...
Oh no! Forget this!
Okay.
Just look at that. What does that mean?
There's a 37% chance.
Is that low? That's pretty damn high! Think of it this way. It's around 1/3, right? It's around 1/3.
Maybe it's around.
That means if he goes to the store 3 times and buys 7 birds each time, this is telling him, on average, he's going to get a rooster in that batch 1 in 3 times. That's not rare. There's an arbitrary cutoff that I taught you guys a couple weeks ago for a rare event. Remember what the percentage was? 5%. And the reason it's arbitrary is due to lots of reasons, but it's used often in you guys. How many of you guys are social scientists and you're psychologists, your early childhood, you guys, 5% is going to pop up all the time in your guys' research. If something happens less than 5% of the time, it's considered to be an outlier, it's considered to be rare, it's considered to be writing about if you see it. So all these, less than 5%, less than 5%, less than 5%, less than 5%, creeping up. And all of a sudden, 12 to 12.4, 37.2. Randall said, look down at 7. When I showed Mike this, he gets it. He's like, okay. The 90% doesn't apply to the entire flock. It applies to each bird in the flock. So when you do 90% of what's happening to the probability as you keep multiplying by 0.9, it's going down. It's going down until eventually it's actually below 50%. You're actually more likely, again, to have a rooster than to not have a rooster. Randall, go.
Is it 5% because it's outside of the second standard deviation?
That is one of the justifications for it, yes. Now, Randall asked the question, why is 5% this standard? Great question. And believe it or not, I encourage you, and you'll do this in 244 if you take me for 244, I go Google the history of why 5% is used as an outlier value. You know what the answer is? Nobody really knows. It's one of those numbers that is set by someone, and the earliest reference I can see. Now here's the deal. Here's the deal. I'm gonna over-answer this question because it's a good question. Suppose this also ties into your fourth project, FYI, which is about false positives and false negatives. Fair enough? False positives, false negatives. Have I asked you guys the question? Have you ever had your car recalled by the dealer? Have I asked you that question before? And many of you raised your hands. Yes, right? When you got your car recalled and the dealer brought it in, did they do anything to your car? Some of you might have something done to your car. Our Jeep just got recalled about 3 weeks ago, and they put a brand new trailer hitch on it. I'm like, the old one was fine. They're like, yeah, we know. Do you know why they would spend all that money to put a new trailer hitch on?
Because someone had power.
Why, Corey? Go. What do you mean when you say not get sued? What do you mean?
Outlier.
What outlier? Go with that.
The one outlier that has a messed up trailer hitch is going to sue them, and they don't want to do that, so they just recall every other.
But now, hang on. I love what you just said, Riley.
It's cheaper.
The one outlier, or the rare outlier that has that messed up trailer hitch that the Jeep doesn't call in to fix,
So they're chasing
that's
that
called a
there.
false negative. That's called a false negative. Negative meaning they didn't identify the problem, but there was one. That's why it's false. Bringing in my car that had a perfectly fine trailer hitch and fixing it is called a false positive. If you increase the chance of a false positive, you automatically, mathematically decrease the chance of a false negative. Now that doesn't make a whole lot of sense probably to you right now because Haley's like, I don't buy that. Don't worry, that's a huge chunk of 244. I'm building a project. Max is actually drawing a cartoon for it. I'm very excited. But that's a huge chunk of understanding 244. As false positive rates go up, false negative rates go down. There's a very good mathematical reason which I have to jump to get to right now. I'd rather not because I'd rather set the stage for it in 243. But that's why so many cars get recalled. They know that they're most likely falsely positive test results, but they'd rather have that than the one outlier. You guys ever seen the movie Fight Club?
Nope. Nope.
No, great movie, set in Delaware, believe it or not. But great movie, and there's a scene in, I won't give the movie away with the scene. There's a scene in the movie, shh, they don't know that, they haven't seen it. There's Brad Pitt is on an airplane, sitting next to a woman who's trying to make small talk and says, who do you work for? And, or no, what do you do? And he says something like, I'm an insurance adjuster, or something along those lines. Say that again.
I was saying Edward Norton.
Edward Norton, no, it wasn't Edward Norton, it wasn't Brad, we didn't meet Brad Pitt yet, did we? It was Ed Norton, yes. And Ed Norton's character goes, I'm an insurance adjuster. And she's like, oh, what do you do? And she said, well, we take the probability of a catastrophic event happening, and we multiply that by the likelihood that someone will sue, and multiply that by the amount that we would have to pay off for each person on average to cover their medical costs should we not fix the problem. So the idea being something fails in a car. And then she goes, oh, that's interesting. And he goes, yes, and if that costs less than it is to do a recall, we just pay out the insurance policies. Now think about that for a second. Why would a car insurance company do that? Why would they say, oh my God, it costs $2 million to do a recall, but if we run the numbers, it only costs us $1.5 million on average to pay out the lawsuits. Let's just pay the lawsuits out.
Because you're saving $500,000.
And that's what Ford did in the late 70s, early 80s with the Ford Pinto. This has become legend now. Exploding gas tanks on the Ford Pinto. Ford, this is a memo that finally leaked out. This would never happen in 2014 because the email chain would immediately get gobbled up. But back then, when you could hide this kind of stuff, they ran the math and they said, okay, we're getting this rare event of fuel tanks exploding. But it's so rare, let's just pay out the settlements when they do explode instead of fixing the problem. Oh boy, yeah. Imagine the Pandora's box of shit that opened up, right? That's that part of the movie is making fun of the Ford Motor Company for doing that back in the late 70s, early 80s. But that's the idea. You don't want that to happen, right? No matter how outlierish, you want to try to minimize the chance of being falsely negative, or in that case, corruptly negative, but falsely negative. And the only way to do that is to increase false positive rates. All of this has to do with what you're looking at right now. That's pretty badass. But right now, you look like you need a break because we went 10 minutes over. But it was a great question, Randall. The arbitrariness of the 5%. It's all tied back to this and that.
What question?
Your question that you asked, where'd 5% come from? Is it outside of 2 standard deviations? Yes, it is. But why not 3 standard deviations?
I don't know.
Why not 4?
I don't get it.
Why not 5?